Relative error. What's relative error, you ask? Well, let me tell you, that's my job. It's a percent, and it's calculated by doing the absolute error over the expected measure. Now, you may remember from a couple videos ago that the absolute error is you go to your measurement and you take half of the smallest measure that you're given. So when I have 48 inches here, my smallest measure is in the ones, and it's 1 inch. So my absolute error is found, and I'll put AE, not for American Eagle, is going to be 1/2 of 1, which is a half, 0.5. So when I want to measure my relative error, and I'll put RE for that, not rendezvous, see vous play. I don't know if that's true or not. Oh, that's RSVP. Apologies. The absolute error is, what did I get? I don't know why I made such a big fraction bar, but it's 0.5. The expected measure was 48. So 0.5 divided by 48 is, let me go to my calculator, 0.0104. Is that a percent yet? No. So to turn that into a percent, you either multiply by 100 or just move your decimal over to the right twice, and your relative error is going to be 1.04%. Pretty small. Now the next one has the possibility of being a little tricky, so don't let it be. See that 0.0? Since that 0.0, that 0 exists as a decimal, that's considered a significant digit. So as tempting as it is to just underline a 2 and say, this is the same as 2, it's not. The 0.02 means that it could be a little bit closer to like 0.2 or 2.01 or 2.9 or something like that. So we're including that 0.0 there. So the absolute error is going to be half of a tenth. Half of a tenth means half of 0.1. And half of 0.1 is 0.05. That's my absolute error. So my relative error is going to be 0.05 divided by 2.0. So when you calculate that, you get a perfect 0.025. Is that a percent? Nope. Move the decimal over twice. And that becomes 2.5%. One more. My number is 11.14, or 11 14/100ths. So my absolute error is going to be half of a 100th. And half of a 100th is going to be 0.005. So the way I calculate my relative error is I do 0.005 divided by 11.14. The absolute error divided by the expected measure. When you do that, you get a terrible number, 0.0004488. Is that a percent? No. Move the decimal over twice. Boop, boop. And so your relative error becomes 0.04488%. Very small, very small, very small. Okay? All right. Simple. Bye.